Okay, example of the washer method from Stewart's book. This is I'm just writing out the region and the axis of rotation. Now drawing the axis, the regions, the axis of rotation, and rotating the volume. Okay, so let's rotate that region. So this point goes about here. This point goes about here. This point goes here. This point goes here. And that's the volume we're interested in. Okay, so the way we proceed is, as usual, we go along the axis of rotation a certain distance. We call that variable s. So that's s. We take a slice through the volume perpendicular through the axis of rotation at that point, and what we get is a region, a cross section that looks like this. So this is clearly a problem for the method of washers. And so I look at the line perpendicular to that touches this at some point, touches the inner that curve at some point, and let's say the x in the original xy coordinates, this has, let me call that x2 y2, coordinates x2 y2, and let us say this has coordinates x1 y1. And so for x2 y2, here are the coordinates. So this entire thing from here to here is x2, this is y2. The rectangle for x1 y1, because y1 is 0, because this is on the x-axis, is squashed. It's this rectangle has no height at all for x1 y1. It's this line itself. So x2 and x1 are the same, and y1 is 0. Okay, now in the rotational coordinate system, so here's r, here's, let's call these coordinates s and r2. So this is r2, the entire length from here to here, and that's the red rectangle. And the length from here to here, let's call r1. That's the red rectangle for r1, and the red coordinates of this point are s and r1. Okay, so now we write down the basic equations between SR, x1, y1, x2, y2. So let's look at the big rectangle. This side is the same as that side, which is the same as x2. So S equals x2. I'm going to write down all the equations about the point which has the subscript 2 first. So S equals x2, and r2, which is this distance, is that distance plus this distance. This distance is y2. This is from this rectangle. And that distance is just the distance of the axis from x equal to 0, and we know that distance is 1. So r2 is 1 plus x. Oh, sorry, 1 plus y2. r2 is 1 plus y2. Okay. And I know x2 and y2, because they are on this curve, are related by y2 equals 1 over x2 squared. And that deals with this point. Now we have to deal with this point. So for this point, this is my red rectangle, and the black rectangle is just flattened down to this line. So R2, R1, which is from here to here, is just 1. It's just this distance. So R1 equals 1. Again, S equals x1. And finally, the point is on this line. So on this line, y1 equals 0. So those are our basic equations. For the disk method, the volume is the integral a to b pi r2 square minus r1 square ds. So we have a couple of things to do now. We have to figure out what a and b are, the limits of s are, and then we have to figure out how r2 and r1 is a function of s. So let's first do a and b. Well, we know s is the same as x2, so the limits of s are going to be the same as limits of x2. And x2 are the x coordinates of this point. So as I move the point along the curve, the smallest x coordinate is this, which is 1. The largest x coordinate is this, which is 3. So I know a equals 1, b equals 3. Okay. Now r2 as a function of s, well, we know that r2 is 1 plus y2. y2 is 1 plus y2 is 1 over x2 squared, and x2 is the same as s, so r is the same as 1 over 1 plus s squared. Now r1 we already know is equal to 1, so there's nothing to do there. So this then equals I'm going to pull pi out, equals 1 to 3 1 plus 1 over s squared, this is r2 squared, minus 1 squared, which is just 1, ds. And all we have to do now is to actually evaluate that integral. So pi 1 to 3, I'm going to expand that square, 1 plus 2 over s squared plus s raised to 4 minus 1 ds, and that equals pi 1 to 3. The plus 1 cancels with minus 1, 2 over s squared plus s raised to 4 ds. And remember that 2 over s squared is the same as 2 times s raised to minus 2. 1 over s raised to 4 is the same as s raised to minus 4. So that integral then, pi, is the integral, well, let me write it out. It's 1 to 3, it's the integral of 2 s raised to minus 2 plus s raised to minus 4 ds, and that equals pi, so this is 2 s raised to minus 1 divided by minus 1 plus s raised to minus 3 divided by minus 3, and the limits of integral are 1 to 3. And now all you have to do is substitute the limits and do the arithmetic to get the volume.